Alrighty, ready. Hello, welcome back to another week of Haskell hacking action. Super exciting, I know. We're gonna continue, I think, probably working on the adventure engine. There's just a few things we need to tie together to put a little bow on the project, and we're gonna get started on those today. So, my idea here is that we want to have some kind of way to author content for the game. And that content is in the form of like all the rooms and the game objects and things like that. And I'm thinking that we're going to want some kind of tool to make adding that content or writing that content out more straightforward. Because currently you can do it with just a plain text editor if you are comfortable editing JSON and you know like all of the keys in our record that need to be present in the JSON object, like what the schema of the JSON object is. And that could be pretty tedious. I don't think that's a good editing experience for this. So if I just bring up the adventure engine and let's bring up our little to-do file here. I'm going to open up our data file here. So we have to generate this game.zip file. And this zip file is what the engine will load and start running. So the game.zip contains all of that juicy content that's going to be in your game. So I'm going to unzip this and we're just going to take a poke. We've seen this a bunch of times in the stream, but if you're just tuning in for the first time, we have these event rewards.json. That's the game rewards for the different things that happen in the game, the score, what you score for doing various things. The game and rewards.json. So the event rewards is what happens during various events. Game end rewards is like the end screen data. So when you complete the game, what happens? And the world.json is the database of all of that describes the entire world. And optionally, we have this folder of images that can be added to give rooms different backgrounds. Right? And this is not going to be terribly fun to edit as an author. First, we'd have to generate all these entity IDs by hand and make sure they're all unique and they link up to the different things properly. That's not going to be fun. And then like formatting your room descriptions here. The dig stuff, if you want to be able to dig in a room, if there's digging stuff. The objects in that room, obviously going to get repeated here with their name and the ID and all that sort of stuff. So probably want to come up with like a better format for writing this stuff out and have a tool that will just compile our input format into these JSON files and a directory of images and all of that, and then zip it all up and create a game.zip file for you. Right? And that's kind of the gist of it. So let's see. I guess the easiest probably the where to start maybe is with the rooms. That's kind of the major thingy thing. Whatever you want to call it. This array of room objects. Or yeah, we'll do it. We'll start there because we also need to do objects like game objects and other things as well. But we can probably get away with leaving that empty for now and just kind of build up to it incrementally. So what are we going to do? We're going to start with creating a new binary, a new thing. We're going to go to our package.yaml. So I have this executable section. The adventure engine exe is the game interpreter. And we're going to just create a new one. We'll call it ADV Adventure Maker. Sure, why not? So main will be main.hs. The source directory for it will be in, well, apps already taken by the Adventure Engine exe. We'll just put it in Adventure Maker. So we'll have to create a directory for that. GHC options. Yeah. Threaded, why not? We'll just copy all that. That's a good default. Okay. So now our project can, when we compile it, we'll create two binaries. The Adventure Engine and the Adventure Maker. Which is all well and good, but we got to create a directory first. Call it Adventure Maker. And that's good. And we're going to, in Adventure Maker, we're going to put a main.hs file. Now we'll just call module main, where, and we'll put Sterling. Hello, Adventure Maker. Boom. Okay. Then I should be able to build Adventure Maker, I believe. All right, we're just going to stack build. So we're building Adventure Engine, and then it should get onto Maker, I suppose. So while that's going, let's float around some ideas about the kind of structure we want for authoring or what a file would look like. I'm thinking that we could have like a room description like this. Let's say we've been using like the front porch in our hard-coded or our example game.zip file with some number of dashes to separate the title from the description. And then maybe some number of dashes again. And then there's a couple other pieces of information. We need items that are here, exits, whether you can dig or not, and what digging reveals. And that's optional. Okay, so we have that built. And then, okay, so Adventure Maker is good. Let's just, don't worry about saving that file. No. Right, so we have that. We need to add Adventure Maker. Stage. Fine. Stage that. Fine. Save it. I don't care. There. Adventure Cabal, main.hs, package.yaml. Yeah. Stage run master. That's fine. Add Adventure Maker executable. Okay. So let's just start with, let's see, the items that are here can be empty. And I don't think we have to define any exits yet. So this might be a good minimal example. I believe exits are also optional. Well, let's look at the engine. We need to look at rooms. So the room name is not optional, and neither is description. So room objects we could just initialize to an empty map. Same with exits as well. It's also a map. Text we have room dig we have to give some text there at least. It could be one or the other. And then background is all optional. It's just a maybe, so we don't have to define anything for that. We could give... We don't have to figure out dig right now. We could probably just give a default value for that. As we try to build like our little pseudo compiler. Really, it's just like a translator. Translation tool. Okay. So this should be the most minimal thing we can get away with, I think. I'm gonna actually make this a file. Test data. Maybe we could put it in data. So I just want like a playground where we can just kind of stuff some example stuff. So example adventure world. We don't really need a file extension to it. Doesn't really matter. I'll just call it world.txt. TXT. People like extensions. Let's create that directory. Okay, put it there. Now, I'm calling this world.txt. Probably should be like rooms or something like that. I'm like thinking if we're going to parse this into a room, well, we might want to put another room in this file. Main hall, for example. Now it doesn't really make a whole lot of sense. How are we supposed to separate these things? It would get kind of annoying to have to define these in different files, even though it'd be very convenient for us as programmers. Inform 7 has a neat way of doing it. It would say like the main hall is a room. And this would be like the title. And this tells you what the thing is. Or, yeah, we could have like special sections, maybe, like I style. And then like, kind of like a prefix for the title. The front porch. Maybe even like markup style. The front porch. And if we wanted another one, we could say the main hall. Yeah, would that work? Hmm. That would make the... it would make the parser a little bit... not too terrible, but... okay, well, let's try this. Let's see how we get on. So we're going to go into Adventure Maker, main. We'll kind of, maybe I'll just kind of put all the files here, not really make it a library. No, we're going to need the library because it's going to depend on that. So we're going to source maker. And we'll create a parser module. That's what we'll start it. Okay, maker.parser. We're going to need autoparsec. And do we have that? We do not. Autoparsec's great is the one I'm most familiar with, but that's because I'm mostly doing like binary type stuff. We might want to use megaparsec for this project. Let me get a browser window here. Megaparsec's just a little bit more full-featured. I can do some pretty nice, interesting things. We don't need to write lexers and all that stuff, hopefully, for this. Yeah. Let's yeah, it's all good. It's a bit of a bigger library than autoparsec, of course, but you get a lot more. So let's go with this. Megaparsec, please. We'll keep this building. Okay, what do I gotta import for megaparsec? Text.megaparsec. Cool. That's pretty much it. A lot of these libraries are going to be fairly familiar. Once you've worked with one parser combinator library, they'll have differences, and they can bite you, but they have a lot of similarities too. Is that mega parsec, like camel case? Nope. Well, that's just fine and dandy. Okay. Megaparsec. So, first thing we have here is like a section. All right. The section kind of determines what all of these things in here are going to be, like what their type is. So over here, it's going to be rooms. We could have a section for items. We could have a section for other things. Exits. This is an okay format. I kind of want to do like an Inform 7 style sort of thing, but I don't know how complicated that would be. For an example, just pointing to the zip files. I want the source. Oh, there we go. All right. Inform 7 is very written like conversationally. It has its own parser for it, all sentence based. I don't know that we could, or if I'm smart enough to do this. Off the cuff anyway. But the idea might be that we could do something like this. Where like the front porch is a room. The front porch. So this gets pretty complicated here. We're not doing all that stuff. We're just really doing descriptions of stuff. Right, you can describe your own verbs. And all this kind of cool stuff. How does it do rooms? It has like this comma colon thing. And then say seems to be the thing when you want to print something out to the user. So we could say like the front porch looks like front porch like this, maybe? Hmm. Or we could put it like that. Have like some sort of indentation. Let's keep it simple. I'm gonna go like this. We'll put the title behind a hash. The description will be all the text following. So like the front porch is spooky. And then we can do a second room. We end if we get to another section. Right, or it's the only one. If there's multiple, we also end on here with like the main hall. And a fascinating geometric pattern. Inlaid. Inlaid in the floor. Inlaid the floor. Inlaid in the floor. I don't know. Inlaid in the floor. Seems weird. We could do it like line by line, maybe? Consecutive lines, and you could just rely on word wrapping. Or if it's unambiguous, we could just, I like to use kind of break up my text, even plain text, or multiple lines like this. This could be all one description, that way we could have multiple lines of it. Like, there are many cobwebs. And this would be 2 rooms. And then I'm thinking if we wanted to add items here, we just have like another special prefix for like items. All right, shovel, purse, and if there's digging available, we'd have just another prefix as well for digging. I don't know. If they're optionally. So you could have like whatever we need to put in here, but we'll get to that later. I think that'll be easy enough to type and work with. So before we get to the item stuff, let's try parsing this. What's going to get a little bit fun with this part is that when we're parsing the room, it's not going to be entirely complete yet because we're not going to have the entity IDs for a lot of this stuff. We might need to get into like partial records and things like that. Take passes on this stuff. Anywho, I'm getting a little ahead of myself here. So let's close that, close in Form 7 stuff. Let's look at megaparsec and what we need here. We run a parsec is what we run in. That's our monad. Monad. Oh, we have a transformer here, a transformer version of it as well. pretty handy in case we want to do like custom error reporting, or we want to do other stuff while we're parsing. I think we'll just start with the basics, parthec. So let's write a section parser then. Section parser is a parsec. How are we going to parse this rooms? Let's see how... Well, we're going to return... a list of something. So we want to be able to have different sections, like item, for example. It's going to be a list. We can't really say what's in the list. It could be a room. If we wanted to have a section parser for items, let's just go with the room parser first. See if we can parse an individual room. Such as it is. Okay, undefined. We're going to need our engine types. Objects. In order to get the room definition. Parsec, parsec, parsec. Is expecting more arguments, right? It wants an error type, right? ESA. E and S. Let's just use text as our E for now. Import data.text. Text. And what else do we got? Oh, input stream type. Okay. Okay. Sorry, I really haven't used megaparsec before. All that much. So I want to just find my own parser type here as a parsec. Yeah, with an error component. Text, say. And then I can do a room parser as a parser of rooms. Is that how it works? Looks like it. Okay. Okay, so the first thing we need to parse with our rooms is the room title. So the first thing we do is we got to match on the car. So let's look at our combinators. Thanks for the follow. Salim 2009. Welcome. Thank you. Much appreciated. So we are going to look for a type thing, car. Might need to import that. A type version of single. Okay, single is maybe what we want. We're not going to keep it, but we are going to just match on it. The beginning of the line. I don't think I have a void. Void control.monad. Maybe, maybe not. I don't know. All right, we got to use our handy dandy apply operator. Okay, so we consume a single pound character. We skip a space. I don't know if we have skip space. So this is going to be a fun time learning the API here. Skip space or spaces. Space. Skip one or more white space characters. Yeah, space one. Okay, cool. So we skip one or more spaces, and the rest of the line is going to be our room title. So we're going to take that with something, some action, and we're going to bind the result of that action, get the room title. And let's see, string, text. What does string do? Synonym for chunk. String prime, same as string, but case insensitive. On success, returns string cased as the parsed input. Okay, sounds roughly good. Where does space one come from? Text megaparsec.car. This might solve our woes. Parser, parsec. Of course, there we go. Well, Salim, are you into Haskell? Are you into interactive fiction? Are you into both? Oh, I see. String's going to parse an actual string. No, that's not quite what we want. We want like a many one sort of thing. Oh, sweet. Well, if you have any questions about what I'm working on or what I'm doing, or want me to explain something, let me know. Happy to do so. So I'm going to find some kind of combinator that's going to let me take many characters. And I'm basically going to take some kind of character set. So what the project we're working on is this text adventure, or more like interactive fiction engine. And I can show you a little example. All right, so when you start up the game engine, this is just demo stuff. So don't pay a huge amount of mind to how awesome it looks. But the idea is that we have kind of this graphical interface where we can input some text and play kind of like a text game, where you input your verbs like walk to the front door. In our demo world, the front door is locked, so we get a little message that says you find it won't budge. But we see here roaring fire, person, shovel. We have other words like pick up shovel. And we can pick up the shovel into our inventory. We get 10 points for doing that. Then we have like the shovel gives us the ability to dig for things. So we're going to dig here. Just our demo kind of world. We win for doing that. So on and so forth. Currently, I'm working on the authoring tools. So this engine will load data dynamically as generated from a bunch of different files. We just zip up into a zip file. So you can make all kinds of different games with it. They're going to be like fairly similar in style. The style of interactive fiction we're going for here is like kind of more of like an escape room sort of thing, where you have to collect different items and move to different places and put them in different places and interact with stuff that way. It's not quite as dynamic as in Form 7 or something like that, which is pretty sophisticated. But this is more of like a learning project, so it's just kind of here to show people that you can build real programs with Haskell. Yes, and you can have background pictures in it as well. So, for example, this room has this kind of just squiggly that I made. If you pick up the shovel and you go through the front door in our kind of demo world with the shovel, it unlocks it. It gives you a little unlock message. You knock on the door with the shovel, and then we get a different background image. And so you can have different background images to go along with the different rooms, that kind of thing. Yeah. Right, so we're building it's editing the data files directly is not very user friendly. So right now I'm working on tools that will let us author tools using like text editors, word editors, whatever you'd like, as long as it's plain text and we can parse it, and then it'll turn it into the appropriate structure for the data files and then create the zip file for you. And so then you can share the zip file with whoever has a copy of the game engine, and they can play your game. It's pretty lightweight, fairly constrained, but yeah, thanks. So we got the room title. String is not the right parser combinator we want here. I need something like many one, something like that. Is there a many one? I'm not sure. Okay, many. There is a many in scope from text.megaparsec. I'm going to duplicate this tab just so I can keep car open. Many. Let's see here. Can I search? How come it's not showing up? That's weird. No, not the search I was looking for. Maybe it's in car? Many? Alejandro Serrano's card game from ZuriHack. Maybe. I don't know. I wasn't at ZuriHack, unfortunately. I don't like traveling a whole lot. But is that talk online, I wonder? I'm gonna fire up my REPL here. Many. Too many type errors. Sweet. I will look that up, because that sounds like fun. Type holes shouldn't block this, but it is for some reason. Not in scope, not in scope. It might help if I was looking at maybe the right version of Megaparsec. What version? Stack's probably a little bit behind. We are using probably a little bit of an older resolver, 18.6. Stackage. For some reason it's not turning up many in this one either. Let's look at accommodators. Maybe that's where it's from. Ah, there we are. Okay. Let's just control one accommodators. Okay, 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 okay. Let's import those. Or the Tix Megaparsec re-exports those, doesn't it? Yeah. Okay, that's why it was there. Okay, I'm just looking in the wrong place. Okay, so many there, many till some. That's the one I want, some. So this is going to apply our parser one or more times. So you need to have at least one character in your room description or your room title. We get some till. When we want to get until the end of line, basically. So we have a parser for the results that we want, what we want to collect, and a parser for the end. So we'll do some till. Let's see if that works. And like new line. Latin 1's probably not the character class. Latin 1 car is probably it. Car category. It would be nice to have Unicode support. Why not a recent GHC? Because I started this project a while ago and I just haven't updated it. Haven't taken the time to update to a newer thing, which we should probably do. There's a bunch of cleanup tasks on my to-do list for this project to get it up to date. Haskell, The Legend of DSLs, Alejandro Serrano. Sweet. Cool. This looks like fun. I will definitely like to watch this talk at some point. Maybe we could do a watch party on stream sometime. So let's try Latin 1 car for now. Just because I'm pretty confident the UI library we're using will support that character set. Probably will support Unicode as well for the most part, but I'm not super sure about that. And we can always fix it later. Right now, I just want to get something working-ish. The minimal thing working? Okay. We get our room title. And the next thing we want to do is a new line. And then we want to collect the rest of the lines and kind of append them together. So we should maybe have like a line parser. Oh, Haskell totally does support Unicode for sure. What I was thinking is we're using a UI library called Monomer. And it's written in, well, it wraps a C library underneath and like SDL and stuff to do the rendering. And I'm not sure exactly how it's rendering text. Right, because this is doing it onto a GL surface ultimately at the very, very bottom. It's all abstracted away from us, but that's ultimately what it's doing there. So I suppose as long as the font set we use supports Unicode as well, it'll do it just fine too. Pretty sure. Something to test with and look into for sure. Yeah, so I can't really make progress with the room parser at the moment because we need kind of be able to just like collect a bunch of lines. Where lines I'm just saying is like any line starting with a character in our character set to the end of the line. And we'll skip over empty lines. Right, and we'll just keep parsing those lines until we hit something that begins with a non. That's gonna be tricky actually to parse. We'll need some kind of terminator. Like maybe dash 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 or something like that. Only because that means you wouldn't be able to start a line in your text that describes a room with any of our special characters. Good night, Salim. Thanks for popping by, and maybe I'll see you next week. I do these once a week on Tuesdays, so. And if you want to catch up later, I do post these also to YouTube as well, at my YouTube channel. And that's at different than Agent Ultra for some reason. It's J. Kenneth King, I think. Anyway, I do post them there. So if you search for like Haskell programming, they'll come up. Yeah, thanks for stopping by and thanks for the follow. Okay, so I'm gonna go line parser. I'm just gonna parse text. In fact, it'll just do it like that. Of course, we have to actually convert to text because we're only getting a list of characters. So we'll bind this, stir to stir. And then we're going to need to import qualified data.text as t. And then we can do pure t.pack. There. Cool. And then we can just use line parser here. Okay. And now let's see. So then we have new lines like this, and we might want several like this. Right? And we want to parse all of these without fail. All right, and line parser uses sumtil, which requires at least one. What we there should be non-empty line parser. Non-empty line parser. And then we could make this work with, so that'll be non-empty line parser for the title, because we require that to be there. Then we could have an just a line parser that would take 0 or more characters until the end of line, returning a text. And that'll just be some, I believe. No, many till, yeah, 0 or more times. We'll just use many till instead. Latin 1 car until new line. And then we pack that up. All right, and then we get room description lines. All right, to be many till and then we'll need line parser here. And our end line parser, our end parser. And then we'll need something that to end it off. And then, once we have that, we can return we can construct our room. And pull that over to the left a little bit. And we'll do room title. T dot onward join line join, something like that. Room name, sorry, is not title, it's name. And data.text. Concat, oh, it's concat, isn't it? Yeah, concat, okay. Okay, then we construct the other things. Objects, empty, Exits, we can just be empty room dig. Do that here. And room. Ba-ba-ba-bum. Is that it? No, can't be. There's something else. Background. What's the problem here? Right. Overloaded strings. We'll add that. Language overloaded strings. Okay, so the only hole we have left here is how we're going to terminate our parsing of the room description. So I think we need some kind of terminating token here. Do like dash 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 dash. We do pound followed by nothing. Yeah. Maybe do that. Maybe that'll be our thing. The pound, not the pound. Single. Okay, does that work? That's the question. Okay, let's pull up our REPL and see our room parser. Awesome. We probably have a function in megaparsec for running our parser. It's probably like run parse, something like that. Parse maybe, parse test. Cool. Let's see. World.text. We can. Let's import data.text.io. That gives us read file. Yeah, I should have imported that prelude. Yeah. Import qualified. Text.io. It's T. Okay. That gives us read file. Easy enough. So I'm going to take our test room. I'll bind it to R, and that action will be .read file. The path will be, I believe in data, example adventure, world.text. And there's R, and then we can parse test. Is that in scope? I have to import it. No, I gotta import text.megaparsec, sorry. Now I got parse test. Cool. So parse test takes the parser first, then the input. So let's do room parser on R. There we go. I got to import my module, of course. And redo all that stuff. No instance for show error component. So it didn't work. We got an error, but for some reason it won't show it to me. Interesting. Error bundle pretty. Hmm. What's this show error component thing here? Void? Okay, maybe we just need to change our this to void in our parser thing. Good times. And we got to import data.void for that. There we go. Okay, it did work. Right, and it just we want to kind of maintain the line separators. So let's fix our parser to do that. When we get many till here, we concat. We don't want concat exactly. We want probably intercalate. With that. Actually, I kind of want to maintain like all the formatting in that block. Interesting. So our line parser. So new line's going to emit. It's going to write up until the end here with line parser, and I believe it's going to omit the consumed new line character. When it runs this parser, it's going to consume the new line and throw it away. So where we have blank lines in our source here, it's going to just discard those. Right, which is how we get this front porch is spooky straight into blah, 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 with no breaks in it. I kind of want to preserve those breaks. So, many till, probably not right. Hmm. The only, yeah. Hmm. That's tricky. How to do that. How do we write a parser that's going to preserve those line breaks? Well, maybe we could say that if string is empty, we didn't consume any characters from here, this thing. All right, if string is empty, then we'll return a string with just a new line in it. Otherwise, we'll pack stir in with t.pack. That might work. Let's try it. So we could put that here if at the length of stir or t.null stir, then let's just put a string else stir. Of course, we haven't packed it yet. Let's see if I can fmap over this action. And we don't need t.pack here. And that should do there. Okay, let's see if that works. Now we're going to have to do all that again. Okay, so then we got the new lines preserved. And maybe we can just strip off the first new line from the beginning. And that'll make it nice. Is there like a strip left? Yeah, strip. Or strip start. Strip seems good. Yeah. Hopefully that takes care of new lines as well. It doesn't. Oh. Hmm. Ah, okay, that's disappointing. What is tail? So text has to be non-empty. Otherwise we'll probably get a runtime error, I guess, from tail. Hmm. Well, we know that it's not null, so it's not empty when we get to this bit here. So that should be safe. Yeah, I think that'll be fine. Compile. And let's try it again. No, it just returned. Oh, weird. Huh. Oh, right. No, we're doing it in the wrong place. Yeah, we're doing, this is the line parser. So yeah, okay. That's, makes sense. We don't need to strip here. I'm doing the wrong place. Silly me. What we should do is it here. There. That's what I think I meant to do. Hopefully. There we go. Yes, so that leading slash n is taken off. Good. And leading line break. And we preserve the rest of the line breaks. Cool. So now we can parse a basic room. Now let's see if we can parse several rooms. Or a section. Right, where we have something like this instead, where we have the main hall. The main hall is great. Okay, so we want to be able to parse this. This from here to here. Let's see. We don't really need this a whole lot, but it is kind of telling us what's in this, what type is in this section. What type of thing we're going to be parsing. So I wonder how to structure this. Section parser maybe takes a text to match. Could be a string. And a parser. Some parser. We can't really say what it's going to parse. But it's going to return a list of those things. A parser that returns a list of those things. Does that make sense? I think that kind of makes sense. And then you'd kind of have to write we'd have to kind of write the section parser for the room section. Room section parser, right, would be section parser for rooms with room parser. And that's how that would work. And it would return a list of rooms. Okay. I think that kind of makes sense. And so basically we need to match that text to this thing here, consuming these brackets. We kind of want to ignore, and then we just repeatedly apply our parser. We can't really say much else, I don't think. With the section parser, we could maybe like require blank lines between each run of the parser that we're given in section parser. Let's just start here with the heading. So the first thing we're going to do is we're going to get a single open bracket character. We are going to match a string of the section name. Is text fine there? Hopefully text is fine there. It might not be fine there. Okay. Make a parsec. Oh, it's maybe in car. What is it? Tokens S. Let's try packing it as a string. Unpack. Hmm. Not quite. Not quite. What's a tokens S? I should be able to do stream text. Hmm. If I just do this, that's happy. This is not happy. Why is no happy? Hmm. Ambiguous type variable, that's all. Oh. Let's give our parser here. Bring that in scope. Maybe that'll make things clear. That's better. Okay. So then let's get rid of that. Unpack section name. cool. It's happy with that. That's fine. Okay, good, good, good. And then we single again here for close bracket. And then we collect our A's together. Our X's, which was really just many P. Okay. So it compiles, but it probably, I'm not gonna assume it's gonna work. I don't think it's gonna work exactly off the bat. I think what's gonna be the trick here is the separator between rooms in the file. So if I load this file up, we have R here printed out, right? We have the front porch, we have the main hall. You can see there's a /n, a pound, a /n, a /n, a pound. Right, just as in the file. Right, /n, a pound. Sorry, /n, then a pound. And then we can, this will be the next, this is where the next room parser can start from. So this blank line between the two isn't consumed by anything, so I figure that's probably where it's gonna choke up. We might get one room. Room section parser. Empty list. Okay. It's not even going to get one because of the first new line in there. So maybe we want, like, we could have a set by parser. Parser of bees. And instead of many, do we have set by? Yeah. So we have a set by combinator. P is set. Well, that we get a type error because we have to pass another thing in here, another parser. So, let's see, we need a new line parser. Okay. Let's load this up into our REPL and give it a shot. Read the file, parse test. Still empty, probably because of the initial new line here. If we made it go like that, that'll probably fix it. No, still doesn't. Oh my god. We have rooms. If it didn't match, that would be bad. Yes. Yep. So we get a parse error there. That's expected. So we can fix that. That's cool. I like that. But set by, it doesn't like set by. What if we took out this second room temporarily? Let's reload that file. Still empty. Just to make sure. Room /n/n pound. And this is just 1/n. Okay. That might be it there. That might be our issue. So I might need to skip a new line here. Or just consume a single new line. And that ought to do it. As long as the file looks like this. So let's restart this again and import that, reload the file, and run our parser. And something's going on with restart the process, please. Aha. Cool, cool. Different parser. That's progress. Okay, set by. Hmm. Hmm. So on line 11, we're getting a Emacs is inserting an EOL character here. And we're expecting a pound character. Interesting. So if I put you back in here, reload the file and pause again, it's still on 11. I change it to that, and I read the file again, and I parse it again. We get down to 15, and we're expecting. So I think we're parsing the 2 rooms now. But section parser is just not knowing when to stop. So maybe if we adjust our room parser. To be single or end of file. Hmm. We can make that. Might need just to fix that up there. Okay, maybe that'll do it. So this parser here, I'm hoping that basically if we have a world file here and we're parsing another room and we get to that end of file, we can either end by consuming this single character or getting to end of file. This may not work, but let's see. We reloaded, so we'll have to rerun all that, and not quite. We're still getting to that empty line, though. Maybe it's more about how we're terminating the section parser than it is about this part. Yeah, that might be it. So we can get many set by p's, but how do we get to the end of a section? So we'll get r's, the results, the things that we're parsing. We'll bind those. And then the last action we'll do is we'll consume either optionally EOF. Oh, or maybe we should use sep end by. Maybe sep end by. The other thing, no, that should be fine. Yeah, sep end by. Let's try that. That might be what I'm looking for. So sep in section parser should be new line or UF. That should be good. Okay, recompile and go over to our repo, read the file, parse test. There we go. Sweet. Okay, so we got 2 rooms parsed there. That's great. As long as you stack up your rooms like this, you should be good to go. Kind of ugly looking, but it works. The main hall, another room. Let's call it another dimension. Here we are, near the end. Prepare for pasta. And we should be able to parse that too once we reread the file. There we go. 3 rooms. Super duper. And there we go. Let's commit that because we are nearly out of time for today. Package that up. Package that up. We don't need the world JSON. We need the example adventure file for testing. And that's it. Cool. New commit. We're going to add maker.parser. This module contains the parser. Parsers for various files. We'll call them author files. Cool. Yeah, looks good. Let's push that up. And there you go. So if this is your first time tuning in and following along, you can get this code and follow this project, fork it, whatever you like, at Agent Ultra on GitHub, Agent Ultra Adventure Engine. And here we are. So fork, star, whatever you like, follow along and check it out. That's all I got for this week. Next week, we'll be back again, Tuesday nights at the regular time, 10 after 8 in the Eastern Standardish time zone. You can follow me, of course, on socials, Twitter, and on the Fediverse at Agent Ultra, at types.pl, and, of course, on YouTube, as I showed earlier. Of course, go to the link above, too. We have a Discord channel there, and plenty of other channels as well for other cool declarative programming languages and functional programming language streamers who you might find interesting. So check that out there. And may all your monads be free. May your types always check. And I'll see you next week.